10.3 goes over solving radical equations. When we are solving these radical equations, we want to isolate the radical. First thing is to isolate the radical. Once we do that, we're going to take the index that is on that radical, which if it's just the square root, it's a 2, and raise each side to that power. By doing that, it eliminates the radical to where you just have what's underneath the radical left over, and then you can solve for your variable. For example, 1a, we are given the square root of x plus 5 is equal to 13. For this one, we want to isolate the radical first. So we're going to move the 5 over by subtracting it from each side. This leaves us with the square root of x is equal to 8. From here, that square root is an invisible 2 index, so we're going to raise each side to the second power. When we do that, the square root and the power cancel each other out, so we just have x is equal to 8 squared, which is 64. For example B, we have 3 minus the square root of x is equal to 0. We could do this one of two ways. We could either move the square root of x over, so that way it's positive, or we can just move the 3 over by subtracting it from each side. We get the negative square root of x is equal to negative 3. We would divide each side by the negative 1 to make that radical positive, and get the square root of x is 3. Once again, that invisible index is a 2, so we're going to raise each side to the second power to cancel out the power and the radical on the left, and just be left with x is equal to 9. For example C, we have the square root of x is equal to 6. For this one, our radical is isolated already, so we're just going to take the index, which is an invisible 2, and raise each side to the second power. That cancels out our power and our radical to where we just have x is equal to 6 squared, which is 36. For example D, we have the square root of x minus 7 is equal to 3. For this one, we're going to move that 7 over by adding it to both sides. We get the square root of x is equal to 10. We take the second power and raise each side to it, and we get that x is equal to 100. For example E, we have the square root of y plus 15 is equal to 22. For this one, we are going to subtract the 15 from each side. This leaves us with the square root of y is equal to 22 minus 15, which is 7. From here, we're going to square both sides, so raise each side to the second power. This is going to leave us with y is equal to 7 squared, which is 49. F gives us 1 minus the square root of c is equal to negative 2. For this one, we're going to start by subtracting that 1 from each side. This leaves us with the opposite of the square root of c is equal to negative 3. From here, we're going to divide each side by a negative 1 in order to make that radical a positive. And we get that the square root of c is equal to 3. We're going to raise each side to the second power so we can cancel out that radical and the power on the left side to just be left with c. And 3 squared is 9. For example 2, we're doing the same thing and just solving each of these equations. Our first thing to do is to isolate that radical. So for example 2a, we're given 4 times the square root of x plus 2 plus 3 is equal to 19. We're going to undo addition or subtraction before we undo multiplication or division. So first thing with this one, we are going to subtract 3 from each side. This leaves us with 4 square root x plus 2 is equal to 16. From here, we're going to divide each side by that 4, because the 4 is being multiplied by that radical, to just give us the square root of x plus 2 is equal to 4. From here, our invisible index on that radical is a 2, So we're going to raise each side to the second power. That cancels out our radical and our power on the left side. So we're just left with x plus 2 is equal to 4 squared, which is 16. From here, subtract your 2 from each side to get your x by itself, and x is equal to 14. For example B, we're given the square root of x plus 4 plus 7 is equal to 11. First thing we're going to do here is subtract that 7 from each side. Those 7's cancel out. We have the square root of x plus 4 is equal to 4. Raise each side to the second power to cancel out that radical. We have x plus 4 is equal to 16. From here, subtract your 4 from each side to get x by itself, and we have that x is equal to 12. For example C, we have 15 is equal to 6 plus the square root of 3w minus 9. For this one, we're going to subtract the 6 from each side to start with. So 15 minus 6 gives us 9 is equal to the square root of 3w minus 9. From here, we're going to square both sides to get rid of that radical. So this gives us 81 is equal to 3w minus 9. We're going to add that 9 to both sides. So this gives us 90 is equal to 3w. We divide each side by the 3 to get w by itself, and w is equal to 30. For the next set of examples, we are dealing with radicals on both sides of our equation. For example 3a, we are given the square root of 2x minus 1 is equal to the square root of x plus 4. When this happens, you want to take the index of that radical, which in this case we're dealing with square roots, so the index is 2, and raise each side to that power. When you do that, it's going to cancel out the radicals on both sides as well as those powers. So we're just going to be left with what's underneath the radicals. So like for example A, will be left with 2x minus 1 is equal to x plus 4. From here, solve your equation like you normally would a linear equation. We're going to subtract x from each side. We have x minus 1 is equal to 4. We add the 1 to both sides. We get x is equal to 5. For example B, we have the square root of 3x plus 1 is equal to the square root of 4x minus 7. Our radicals on both sides here, so we're going to take the index, which is an invisible 2, and raise each side to the second power. That cancels out our radical on both sides, so we're just left with 3x plus 1 is equal to 4x minus 7. I'm going to move my 3x over by subtracting it from each side. We have 1 is equal to x minus 7. Then we add our 7 to both sides, and we get that x is equal to 8. For example C, we have the square root of n is equal to the square root of 5n minus 1. For this one, again, we're going to raise each side to the power of 2 to cancel out those radicals. We're just working with n is equal to 5n minus 1. You want your n's on the same side, so bring that 5n over by subtracting it from each side. This leaves us with negative 4n is equal to negative 1. And from here, we're going to divide each side by that negative 4. A negative divided by a negative is a positive, and n is equal to 1/4. If we look at example 4, we're solving each of these equations, but now we're dealing with the cube root. So the same exact thing applies. Isolate the radical, take the index, raise each side to that power to cancel out the radical, and then work with the equation, solve for the variable. For example, 4a, we have the cube root of 5x minus 2 is equal to 12. Your index here is 3. So you're going to take each side and raise it to the third power. From here, that will cancel out your radical and the power on the left side to where you just have the 5x minus 2. Next, you have that 12 to the third power. 12 to the third power is 1,728. From here, you're going to add the 2 to both sides. You'll be left with 5x is equal to 1730. From there, you're going to divide each side by the 5. 5 goes into 17 3 times with 2 left over. 5 goes into 23 4 times with 3 left over. 5 goes into 30 6 times. So x is equal to 346. For example B, we have the cube root of y minus 4 is equal to 1. For this one, we're going to start by adding the 4 to both sides to isolate the radical. We have the cube root of y is equal to 5. We raise each side to the third power, and we get that y is equal to 125. For example C, we have the cube root of 3c plus 7 is equal to 10. Again, we have an index of 3. Our radical is isolated, so we're going to raise each side to the third power. This cancels out our radical to leave us with 3c plus 7 is equal to 1,000. From here, we're going to subtract the 7 from each side. 1,000 minus 7 gives us 993. So 3c is equal to 993. We divide each side by the 3, and we get that c is equal to 331. For example 5, we have equations that involve a radical and a variable. So we're going to do the same thing that we would in the questions previous to this to isolate the radical, then get rid of the radical, and then we're going to solve for the variable. When you solve for the variable for these, you're going to be using square roots, cube roots, and so on. So you just have to be careful with that, so that way you remember your rules with solving for those. So if we look at example 5a, we are given x is equal to the square root of x plus 6. You have the square root. The index on there is 2. So we're going to raise each side to the second power. X to the second power is x squared. The square root of x plus 6 to the second power is just x plus 6. You have an x squared. So bring everything to the same side as that x squared and solve by factoring if you can do so. The x we're going to subtract from each side. You do not have like terms, so that gives you x squared minus x is equal to 6. From there, subtract the 6 from each side. Again, no like terms, so that gives you x squared minus x minus 6 is equal to 0. From here, you want to find the factors of negative 6 that add up to be a negative 1. If you have 2 and negative 3, that adds up to be negative 1 and multiplies to be negative 6. So this factors out to be x plus 2 times x minus 3 is equal to 0. Set each of these equal to 0 and solve for both of them. You have x plus 2 is equal to 0, which you will subtract the 2 from each side, and you get x is equal to negative 2. You also have x minus 3 is equal to 0, so add the 3 to both sides, and you also get that x is equal to 3. So negative 2 and 3 are your two solutions for this example. For example B, we have the square root of 4 minus 3x is equal to x. We're going to take each side, raise it to the second power to cancel out that radical. We have 4 minus 3x is equal to x squared. Once again, you have an x squared, so move the 3x over, add it to both sides. You have 4 is equal to x squared plus 3x. Then move your 4 over by subtracting it from each side. You have x squared plus 3x minus 4 is equal to 0. Find your factors of negative 4. That adds up to be a positive 3. If you have negative 1 and positive 4, that gives you a positive 3 when you add them. So this factors out to be x minus 1 times x plus 4 is equal to 0. Set each of these equal to 0 and solve for both. For the x minus 1 is equal to 0, add your 1 to both sides. You get x is equal to 1. For x plus 4 is equal to 0, subtract the 4 from each side. You get x is equal to negative 4. So your two solutions are 1 and negative 4. Now, if you look at both of these problems, you can check your answers and plug them into the original problem. If we look at example A specifically, your two solutions are negative 2 and 3. These are solutions. Whether you want to admit them or not, they're solutions. If you plug them in, that negative 2 is going to give you a false statement. Because it gives you a false statement, so for example, if you plug it in, you'd have negative 2 is equal to the square root of negative 2 plus 6. Well, the square root of negative 2 plus 6 is the square root of 4, and the square root of 4 is not negative 2. So when this happens, you have something called an extraneous solution, which just means, yes, it's a solution, but it does not work. So this negative 2 in this case, you would identify as an extraneous solution. Same thing with example B. You have 1 and negative 4 as solutions. If you plugged in that negative 4, you would get the square root of 4 minus 3 times negative 4 is equal to negative 4. 3 times negative 4, negative 3 times negative 4 is 12. 4 plus 12 is the square root of 16, which is not equal to the negative 4. So once again, that negative 4 is an extraneous solution. If we look at example 6, for A, we're given 13 plus the square root of 5n is equal to 3. First thing we're going to do is, for this one, is subtract the 13 from each side. We get the square root of 5n is equal to negative 10. From here, we would take each side, raise it to the second power. These cancel, so we have 5n is equal to 100. To get n by itself, you would just divide each side by 5, and n would give you 20. Now, if you were to plug this in, you have 13 plus the square root of 5 times 20 is equal to 3. This becomes 13 plus the square root of 100. And 13 plus 10 does not give us 3. So this here is also an extraneous solution. For example, B, you have the square root of 3m plus 10 is equal to 1. For this, we're going to subtract the 10 from each side. you get the square root of 3m is equal to negative 9. This is your dead giveaway, by the way, that you're going to have an extraneous solution, because the square root of anything is never equal to a negative number. Just like when you had the square root of 5n is equal to negative 10 in the question before this, it's a dead giveaway. You're going to have an extraneous solution. You can never take the square root of a number and get a negative, which is why, again, it's a dead giveaway. From here, square both sides, cancels out the radical. You have 3m is equal to 81. We divide each side by the 3. 3 goes into 8 twice with 2 left over. 3 goes into 21 7 times. So m is equal to 27. Again, this is called an extraneous solution. And even if I wanted to check it, I could plug my value in. So I'd have the square root of 3 times 27, which is the square root of 81, plus 10. 9 plus 10 is not 1. The last example that we're going to be going over in this lesson, you have p plus 1 is equal to the square root of 7p plus 7p plus 15. For this one, you're going to square both sides to get rid of that radical. When you do that, that entire part on the left side, that p plus 1 gets squared. So use your perfect square trinomial. You have an addition sign in the middle, so you're going to do p squared plus 2 times p times 1, which is 2p, plus 1 squared, which is 1, is equal to 7p plus 15. From here, move your 7p to the other side by subtracting it from each side. We get p squared minus 5p plus 1 is equal to 15. Next, we'll subtract the 15 from each side. And you get p squared minus 5p is equal to minus 14 is equal to 0. Find your factors of negative 14 that add up to be negative 5. You have 2 and negative 7. So this factors out to be p plus 2 times p minus 7 is equal to 0. Set each part equal to 0 and solve. So p plus 2 is equal to 0. P minus 7 is equal to 0. Subtract your 2 from each side. You get p is equal to negative 2. So add your 7 to both sides. You get p is equal to 7. Check them. If you plug in the negative 2, you have negative 2 plus 1 is equal to the square root of 7 times negative 2 plus 15. Negative 2 plus 1, negative 1. You have the square root of negative 14 plus 15. That's negative 1 is equal to the square root of 1. Negative 1 is equal to 1. Not a true statement. So that negative 2 is an extraneous solution. Check the 7 also. So 7 plus 1 is equal to the square root of 7 times 7 plus 15. 7 plus 1 is 8. 7 squared is 49. 49 plus 15 gives us 64. The square root of 64 is 8. 8 is equal to 8. So this one is an actual solution. So you have p is equal to 7 and an extraneous solution of p is equal to negative 2.